Multiple angle formulas. We know that we could replace our 60 with a 2 times 30. The question is, can we take this 2 and bring it in front like we're doing over here? And we want to know, does that side there equal this side? Well, you should remember that the sine of 30 is a half, so it's really 2 times a half, which is 1. Over here, it's still the sine of 60. Is the sine of 60 equal to 1? No, that's a root 3 over 2, so obviously not. So we cannot just go ahead and pull a number out and put it in front of our sine. And so since we can't do it here, we can't pull that 2 out. We can't pull the half out here. So whether it's a fraction in front of your angle or a normal number in front of your angle, in neither case can you actually pull that number out. So how do we deal with multiple angles, meaning a number in front of an angle? What we want to do is we want to go ahead and use our double angle formulas. When you're dealing with a 2 in front of your angle for your sine, you want to go the sine of that initial angle times the cosine of that initial angle times a 2. Now that really comes into play because you know that 2u is really a u plus a u, so you could use your sine of alpha plus beta formulas from last lesson. So you go the sine of u cosine of u plus the sine of u cosine of u. So that's really just two of these sine of u's cosine of u's. And so that's how we come up with that. And you can repeat a very similar process with the cosine of u plus u, or the cosine of 2u, to be able to come up with your double angle formulas for cosine. So here's your double angle formula for cosine. Using your Pythagorean theorem identity, you could rewrite it like this, or you could rewrite it like this. So your double angle cosine has three options for you. We also then have your double angle for tangent, which is given to you with this. And that can also be done by going the tangent of u plus the tangent of u and working that formula out. Or you may choose to use or think of tangent of 2u as being the sine of 2u over the cosine of 2u. Either one will work and accomplish what you need. We also have half angle formulas. Half angle formulas are given to you down here. Now, whether it's a plus or minus all depends upon the context of the problem that we'll deal with later. So, here we have the sine of 2u, the cosine of 2u, and the tangent of 2u that we want to find. The only thing you're given is that the sine of u is negative 4/5, and that you're dealing with from 270 to 360. 270 to 360 is really the fourth quadrant, which should make sense because you're dealing with your sine here being negative, and sine is negative in the fourth. It's also negative in the third, so that's why we needed this additional piece of information to limit us just to the fourth quadrant. So you're going to draw yourself a triangle in the fourth quadrant, so draw your axes. You always come out from the origin into the quadrant you want, which in this case is the fourth quadrant. So you always come out from the origin into the fourth, and then always make a right triangle to the x-axis. Sine, you should remember, is, oh, and your angle is always at the origin in your triangle. Sine, you should remember, is opposite over hypotenuse. So it's the negative 4 over the 5. Keep in mind your hypotenuse is always positive. You could use your Pythagorean theorem then to figure out your missing side. Well, let's go ahead, now that we have our diagram drawn, figure out if we double that angle, what would be the sign? Well, let's use our double angle formula, cosine, or double angle sine formula, which is 2 sine u cosine u. So it's going to be 2. The sine of u right here, you know sine is opposite over hypotenuse. Then you're asked to figure out the cosine of u. Cosine, you should remember, is adjacent over hypotenuse. And then all we have to do is simplify that down. It's really a 2 over 1 times 2 more fractions. You could do that in your head or on your calculator, and you get negative 24 over 25. When you're dealing with the double angle for your cosine, you have a couple of options, really 3. I'm going to choose to use this option. The reason is because since I'm given the sine of u, I'm going to use the formula that has the sine of u in it. So I'll go 1 minus 2, and then the sine of u, which is your negative 4/5, I'll put in there, and then square it. You might be saying, well, it is negative. Yes, it's negative, but if you square it, it really doesn't make a difference. So then you can type that into your calculator or do it in your head. Doesn't make a difference, and you get a negative 7 over 25. You're also asked to figure out the tangent of 2u. You really have a couple options. One of your options is to say, well, tangent is sine over cosine. So the tangent of 2u would be the sine of 2u over the cosine of 2u. The cosine of 2u we have right here, where the sine of 2u is here. So all we have to do is just plug those in, and then you have a fraction over a fraction. So you multiply by the reciprocal. It's also a negative over a negative. And we get a 24 over 7. You could have chose to use the double angle for tangent, the other one. So you would want to go ahead and figure out the tangent of u. Remember, the tangent of u is opposite over adjacent. So I'm going to go 2, my opposite over the adjacent, go 1 minus, and then tangent of u, which I just figured out, and then double the top. I get this, double or square the bottom. The bottom simplifies down to a negative 7 over 9. Fraction divided by a fraction, so I still am going to get the same answer, 24 over 7. Either one doesn't make a difference. They both give you the same answer.